And then really they're confronted with an opposite set of circumstances. Suddenly, there's as many points of view as there can possibly be, all right? And the problem, or the challenge, is to establish authority. And self-awareness is going to be key if we're to learn how to make decisions about what information to accept and what information not to accept in the digital age.
Hello and welcome to Random Walk, a podcast about interesting things I stumble upon. I'm your host Adam, and I'm currently tired, bored, and terrified by election coverage. The Canadian and American federal elections are coming up. This time around, it seems like there's just as much discussion about the integrity of the candidates as there is about the media reporting on them. Fake news has become a globally recognized hashtag, one-line comeback, and an agonizingly slippery threat to democracy. And I hate it. I hate the term fake news. It's ambiguous and it doesn't really mean anything. So instead of concerning ourselves with fighting fake news, let's look at some of the ways news media can be misleading. Note that this doesn't mean someone is trying to trick you. Sometimes the most misleading stories are the ones that are just misinterpreted, which is scary because the information can just as well come from someone you trust as someone you don't trust.
You know, as we face the challenges of jobs, creating jobs, losing jobs, the last thing that we need are NDP policies that are going to damage our competitiveness, things like a royalty review, 20% corporate income tax, which would give us a higher corporate tax rate than BC.
What are you
Ontario,
talking about? Our proposed corporate tax rate is 12%. I'm not sure who's briefing you, but I just do need to clarify that
10% to 12%.
Absolutely incorrect.
I know that math is difficult, but
no. If you're saying
10%
it's 12%,
to 12% is a 20% increase.
You said a 20% tax.
If I might
say increase.
So
I just need to make that clear that we're not proposing a 20% corporate tax. That would be ridiculous.
If I might carry on.
Ooh, remember that one? Canadians, that was a 2015 deep dive into an Alberta debate. It was between Rachel Notley and Jim Prentiss. So to summarize, Jim misspoke, calling out Notley for proposing a 20% corporate tax. In reality, she was proposing an increase from 10% to 12%. So this mistake is understandable, but the clip lives on as this gross caricature of mansplaining. And for those keeping score, Notley beat out Prentiss in the following election. But there's some truth to what Prentiss was saying. Some math is hard. But the kind of math that surrounds most news stories isn't, or it doesn't have to be.
So I have made a career of investigating things using numbers.
So that there is our guest this week. That's Dr. David Venus. He's a professor in the Physics and Astronomy department at McMaster University. And I had a chance to sit down and talk to him about the news.
Well, yes, and the whole issue of fake news is an important one. Mm-hmm. But the one thing I would point out is that fake news is a subset of all the misleading information. There's a whole bunch of very well-intentioned people putting out arguments that are not necessarily trying to mislead you, but you still have to try and decide, is that believable or not believable?
So why am I talking to a physicist about news media? Well, good question. See, David's a very smart guy, and over his career has become very skilled at a certain number of things.
When I do an experiment, all I get is a huge table of numbers. And I and my graduate students, we have to interpret and create a story out of the numbers. And so I'm used to doing that. And it, for me, is very natural. And it's natural for me to think of mathematics like language and numbers like words. But again, this is a very artificial environment. And when we go outside into the real world, we'll call it the real world, this world where we're trying to make sense of the information and make decisions, I've really noticed that the story told by the numbers is almost entirely discounted or presented in what I find very strange ways or misleading ways. The important thing is that we're not talking about complicated stories. We're talking about numbers telling a story of context. We're talking about simple things like fractions and percents. And people learn things in one context, like a classroom or a mathematics class or a statistics class. And it's difficult to change contexts and to recognize the context where that can be used very simply. For instance, when you're trying to understand some news stories.
I work in the same department as David, but it wasn't until I saw his name pop up on an opinion piece published in the Toronto Star that I realized he was into the media like this. The first thing of his that I read was inspired by a book, Thinking Fast and Slow, by Nobel laureate Daniel Kahneman. In this book, Kahneman defines 2 ways the brain makes decisions. Process 1, which is fast, unconscious, and based on emotion, and process 2, which is slow, methodical, and logic-based. In David's article, he proposed that the reason it always seems like we're making the logical decision and everyone else is getting caught making rash, emotional ones is that our brain is only aware of the decisions we make via process 2. Effectively, we're blind to our own process 1 decisions. Now, this isn't to say that process 1 decisions are any more or less important than process 2. They just serve different purposes. And when it comes to understanding the news and understanding stories that people are telling us, it's more useful to engage our process 2 ways of thinking.
Our system 1, which gives us our gut reaction, there's very little emotion in numbers. There's nothing to latch onto there. So as soon as we encounter numbers, we go automatically right to our slow thinking. And suddenly we are conscious of making a decision. And so my sort of approach on this is not to say that our analytical thinking is better or worse. To agree with evolution, and we need both. It's just the thing we have to try and deal with is one is unconscious and one is conscious. And we just want to make sure, I think, that when it comes down to it, we're making more conscious decisions. We're not all perfect. We don't necessarily know the absolute truth to everything we write or communicate, or right? And we're all operating with the same system 1 and system 2, right? I might be very good in understanding some of these numerical questions that I'm used to thinking about. Put me in a different sphere, in a situation where there's emotional content for me, then I'm useless too. That's the key thing about this article, right? To recognize that we all have to try and learn how to work with the way that we think, the way it's been constructed, right?
You always have to be careful with pop psychology like this. It's a very attractive theory, but I don't know how scientifically accurate it is. But for our purposes, we can take this process 1, process 2 model and use it to understand the point David's trying to make. We don't want to make gut decisions about complicated issues. We want to stop and think about what we are reading and hearing before making any decisions. So David's not a psychologist. So where does his expertise fit into this problem?
So while there are many ways that we can train ourselves to do this slow thinking, this system 2 thinking, and not only have a gut reaction, the one that I feel I can contribute to is what I call media numeracy, as opposed to what many people would call media literacy, which concentrates on the story that's right there in the words or in the voice if it's an audio presentation. And so I concentrate more on the idea of media numeracy and developing the idea that the numbers are telling a story too.
And this problem is what inspired Dr. Venus to start a course called Media Numeracy. It's a second-year course held by the physics department, but it features no physics, and it's open to everyone. The goal of the course is to develop a basic toolkit to better understand the story being told by the numbers. So let's rewind and take another look at that cringy clip from the top of the show.
But
no, if you're saying
10%
it's 12%,
to 12% is a 20% increase.
You said a 20% tax.
If I
You
might
didn't say increase.
If
so
I might
just need to make that clear, that we're not proposing a 20% corporate tax. That would be ridiculous.
If I might carry on.
Okay, did you see what happened there? Prentiss was taking aim at a tax increase from 10% to 12%, but claimed Notley was raising the tax to 20%. Okay, so it's debatable whether that misspeaking was deliberate, but the confidence with which Prentiss spoke and defended himself and the resulting confusion could easily leave listeners unsure what the actual figures were. Maybe this could cause them to tune out to the details. Maybe this could coax people into making an emotional decision about the two. See, being comfortable around basic algebra could help you not get sidetracked by the scrum. Now, I'm not going to take you through the whole course. We just don't have time. So let's focus on one concept, a concept so important that I got a little tattoo about it.
The whole idea that a number is not a number, but there's some range. And the range might depend on how it's measured. It might be because there's a poll and they asked a certain number of people. I mean, everybody knows that you don't learn very much by going out on the street and asking one person their opinion. Right. And people also know that if you ask more people, you get a better sense. But we don't have much intuition about how many people we should ask to have how much confidence in what they're telling us on average. All right? And my favorite example of this sort of effect has to do with our education system and what's called the Education Quality and Accountability Office, which the province of Ontario has. And this was set up for the very laudable goal of understanding and trying to measure are elementary students learning the math and literacy skills they should be learning. And so they set up a series of annual tests, standardized tests, and all the grade 6 students take the math test, and then all the answers, they're all marked and so forth. And then they tell us what the results are and they interpret them. And this has been highly contentious for a long time. And the government says we should be accountable, people should know what's happening. But the teachers in the schools feel that this is counterproductive for the educational process and that it's not helping learning at all. And so there's 2 points of view here, and as is often the case, I think that there's a real middle ground that very simple numeracy skills can help us understand. I mean, when the government puts together all the tests from all the grade 6 students, there's about 130,000 of those in Ontario. And so they say this percentage have passed the test. And the second thing they can calculate using a very simple formula. The simple formula is you take 100 for a 100%, and you divide it by the square root of the number of people writing the test. So for the province of Ontario, it's 100 divided by the square root of 130,000, sorry. And so this means the answer, the average they get, if it moves by 0.3%, this is a meaningful change. And so province-wide, they can claim that, these changes in how students are doing are meaningful and they should be interpreted.
All right, wait. Let's talk about this square root business. So he's not lying when he says a lot of this numeracy toolkit is just algebra, but where some of these techniques come from is a little bit more complicated. So let's dig into this one a little bit. Remember bell curves? Think about the marks you got in class. There's an average mark, where most students are located, and then there are marks that are higher and lower. Less of them, though, as you get further from the average. That's generally the case for events that don't affect one another. This is a general class of events, and students taking a test is a pretty good example of this, provided they're not cheating or helping each other or anything like this. In this case, the distribution of grades should look kind of like a bell. Has a peak in the middle where most students are located, and the number of students receiving higher and lower marks decreases rapidly away from this average. It's actually amazing how many things follow this sort of distribution, but that's a story for another podcast. The important thing is that the more students that take the test, the higher the peak will be relative to the width of the bell, and the more certain you're going to be of what the average value is. For example, if you have 3 students taking a test, you're not going to get any sort of bell shape, and you're going to have a very hard time trying to predict what the average score of students is going to be. Now, where the square root comes from in particular, so that basically comes from the idea that more measurements will make the bell look thinner and pointier. And so this is going to give you a better constraint on the range of test scores that you can expect.
And now when it comes down to the Board of Education, like the Hamilton Wentworth Board of Education, there's now 3,500 grade 6 students. And so when their score changes, if it changes by 1.7%, then this is meaningful. Mm-hmm. And so that's still a reasonably small number, and you could imagine tracking that and seeing if your local initiatives are making a difference. Mm-hmm. But then it comes down to the individual teacher, the grade 6 teacher who's teaching math in their school. Most of our schools in Ontario, our elementary schools, are not very large. Mm-hmm. Most of them have just one grade 6. There's just 30 students in that class. And now 100 divided by the square root of 30 is 18%. That score is only good plus or minus 18%, which is a huge variation. Mm-hmm. One year it might be up 18%, the next year it's down 10%. It can easily fluctuate all around.
From a C plus to an A minus, effectively?
Effectively, yeah. Bouncing all around entirely because of the way numbers work, of what's called sampling and statistics. But it's a very simple idea and a very simple formula that anybody could use. And the teachers are saying, well, my score went down by 18%, and now all the parents are unhappy, and I'm being visited by a special team from the Board of Education about my teaching methods. All these things are happening. I'm being judged on statistical fluctuations. Mm-hmm. This is entirely unproductive. And the province of Ontario is taking the opposite point of view. All these changes of 0.3% really mean something. And so here's a situation where a little bit of media numeracy will go a long way. Because the individual parent, where did they get their information from? They read all these articles. They look at, for instance, the Fraser Institute on their website does a ranking of all the schools in Ontario. And the parents say, oh, look, this one here has a low score. I'm going to buy my house the next block over because that school has a much higher score. Mm-hmm. And the Fraser Institute ranks all these people make investments according to their house of $1 million, $500,000, all based on statistical fluctuations. Mm-hmm. It's amazing. And then to compound things, what happens at the Board of Education level? The Board of Education, of course, wants to have accountability, wants to have the math program delivered well, and so they say, which schools are particularly low? How can we help them? And so, of course, the ones that are particularly low have a combination of demographics, the families, teaching efficiency, but also these very large statistical fluctuations. The ones that are particularly low have a low statistical fluctuation that year. So they've taken scarce resources at the board level and made this kind of SWAT team that goes in to address this. Mm-hmm. And has a 1-year plan to bring this score up. And they are spending all this money when they could be spending on other educational initiatives to do that. And they're absolutely convinced that they're doing a good job. And why are they convinced? Because they say, you see, the next year the score went up because of our intervention. Completely missing the idea that there's these big statistical variations because there's only 30 students in the class. Mm-hmm. And if 1 year things are fluctuating down, on average they're going to fluctuate back up the next year. And it wasn't the SWAT team at all. Mm-hmm. So this kind of example, which we can find all through our media, all through the important questions in our society, numbers are not the only story there. There's lots of other stories. There's the question of, does the test measure anything? Is it a valid test? Is it measuring the proper thing? I mean, I'm not saying this is the only approach, but it's certainly an important component, and it's the component that it's an example of the kind of situation that I am focusing on in this course. What I try to develop is what I call a toolkit, a numeracy toolkit, and there's about 10 or 11 ideas, all that can be written out in one line. The most complicated thing that's required is for a student to take a square root on a calculator, right? It's all what I would call high school, grade 10 at most, likely even elementary school mathematics. But a lot of people, as you say, confronted with numbers, they are inhibited. And this is another thing we cover in the course, looking again for that balance.
Unfortunately, that's all the time we have this week, but there's a lot more content like this on its way. I recently read an interesting article on fake news during the French Revolution, and a scary research paper on how people can make false memories in the face of factual evidence. So that's coming. If you like the numeracy stuff in this episode, great news. I'm TAing Dr. Venus's course next semester, so I'll be able to dig into it a little bit more. That said, I'd like to thank Dr. Venus for talking to me. If you're a McMaster student, consider taking the Media Numeracy course offered by the Physics department. I'll put a link to the course and a few of David's opinion pieces in the show notes. I'd also like to thank my friends Booney, who just keep letting me use their music. Follow them on Spotify or visit them at booney.rocks. And if you'd like to keep up with me and my writing, you can find me on Twitter at Adam, Fortais. Thanks again for listening, and I'll talk to you later.
It's not so